Hey, welcome back to your favorite pre-calculus class. We're going to look at composite functions. We're going to form them, find the domain of them. Get my pen here. Let's look at this an application in the real world. Let's say you had this oil tanker. It's leaking oil. So, for instance, over time, you're going to have this radius is going to be increasing over time, right? That radius as the oil gets bigger and bigger and bigger. So let's say for a minute that this radius is defined as 3 times the number of minutes, t in minutes. So, for instance, after 20 minutes, if you're reading this thing is 60 feet is your radius. Well, what's the area of this thing? Well, we know that the area of a circle, area is a function of the radius, it's pi r squared. But your radius is changing. Radius is a function of time. So what you can do is you can create a function where area is defined in terms of the time, and that's what you would have to do is you got to replace the radius here with the 3t. In other words, you make the r into 3t. So you would replace like this, so the f function goes into the g function, or g function goes into the f function, if you will, in terms of this definition that I'm going to show you here in a minute. And then you just clean that up. You got 9t squared. So now your area is in terms of the radius, which is a function of the time. So for instance, if your time is 20 minutes, now you can punch it in here, 20 minutes. Right, you square, you got 400 times 9, you got 3600 pi, would be how large this this area is, how much oil is spilled. Okay, so here's your formal definition. F of g of x is how you say this. F of g of x is how you say that. Okay, f of g of x equals f of g of x. There's two notations here, that one, and then the function notation there on the right. So let's do some examples here, or let's talk about, I'm sorry, let me go back to this for just a minute. Notice your x is going into the g, and then the g is going into the f. Okay, so the x goes into g, and then g is input into f. Okay, so x is going in through g, and it's giving you your y value, your g of x, and then g of x becomes the input into f, and it spits out that y value, which we call f of g of x. Here's with your function, your function machine. Your input x goes into g, spits out g of x then goes into the f and spits out f of g of x. Okay, so let's do some problems here. Let's put this into the function notation, f of g of 1. So what we're going to do is we're going to go to the side and we're going to figure out what g of 1 is first. So we know g of x here is defined as 4x. G of x is 4x. What would g of 1 be? Well, it'd be 4 times 1, which is 4. So this 4 goes in for g of 1. So now I'm finding f of 4. Well, since f of x is 2x squared minus 3, 2x squared minus 3, and then our 4 goes in right there. So we got 2 times 16 minus 3, so we got 32 minus 3, which is 29. Okay, let's do this one, g of f of 1. G of f of 1. So first I'm going to go to the side, and I'm going to find f of 1. Well, f of x is 2x squared minus 3. Find f of 1, 2 times 1 squared minus 3, so we got negative 1. So f of 1 is negative 1, so that becomes negative 1. So now I'm finding g of negative 1. So I input negative 1 into g. Well, g of x is 4x, so I got 4x, but what goes in? That negative 1. So this ends up being negative 4. And that's how you're going to work these. Here's the other ones. You know, f of negative 2. You're going to find the f of negative 2, which ends up being the 5. And you put the 5 into the f. And you end up with 47. G of negative 1. Find the g of negative 1 first, which is spits out a negative 4. Then put the negative 4 back into the g function. So you have 4 times that negative 4, which is negative 16. Okay. In fact, I'm going to skip ahead to this last slide while I'm thinking about it, and then I'm going to come back. So this is looking at it instead of with the equations, we're going to look at it from the visually. So let's find, the first one says find g of f of -1. So what we're going to do is we're going to find f of -1 first. So I'm looking on my f function, the lower one there. I'm going to find f of -1. So I go to my x value of -1, and I'm looking, I'm like, okay, it's right here. When x is -1 on the f function, my y value is 1. So f of -1 is 1. Now I'm finding g of 1. So I go to my g function, the upper one, I go to an x value of 1, and I find that when my x is 1 on the g function, my y value is 4. So g of 1 is 4. In other words, g of f of -1 is 4. This is 4 equals 4. Okay, let's do this one now. F of g of -1. So let's find g of -1. So I'm going to my upper function, g of -1. When x is -1, y is 3. So I replace g of -1 with 3. And now I'm finding f of 3. So I go to my lower one. I find when my x is 3, I'm right here. F of 3 looks like it's -1. And that's how you're approaching those. Let's do one last one. Let's do that g of f of 0. So find f of 0. That's my lower function right there. F of 0 is 0. And then find g of 0. So I go to my upper function right there. G of 0 looks like is 5. Okay. Alright, let's go back now. And let's find, oops. Now let's find the functions without the values. So let's find f of g here. So let's find f of g. So first I'm going to find what's my g. That goes in. Well, my g of x is 4 over x minus 1. Okay, so 4 over x minus 1 is going to go into f. So now let's write f. F of x is 1 over x plus 2. But what goes in? X doesn't go in. This stuff goes in. That's my new input. G of x is input into f, so it's 4 over x minus 1. Now, after I clean this up, that's my function f of g of x, okay? But it's right here that I want to look at my domain, because my domain, if you go back to that definition, is a set of all x such that it satisfies g, such that it satisfies f, okay? So right here, right when you plug it in, don't solve it yet. Think about your domain initially, and you say, well, x can't be 1. My domain is going to be all reals, and I'm going to be throwing out, I'm already throwing out 1. Okay, now let's clean it up and see what this function becomes, and see if we have to throw anything else out. Okay, so this is 2 over 1, get a common denominator, and this becomes f of g of x equals 1 over, I've got this 4 plus 2x minus 1. This is all over my x minus 1 now. So I got 1 over 4 plus 2x minus 2 over x minus 1. So I got 4 minus 2 is 2. 2 plus 2x over x minus 1. And I'm going to multiply by x minus 1. It's reciprocal here. 2 plus 2x. Got to do it to the top. X minus 1 over 2 plus 2x. So this becomes x minus 1 over 2 plus 2x, or if you want, x minus 1 over 2, 1 plus x, or x plus 1. Okay, there's our function. Now at this point, say, is there anything else where we're undefined? Well, x can't be -1 either, because now we're in the simplified form. If x was -1, we'd be undefined. We can't divide by 0. So there is our domain for this one. So right when you plug it in, that's when you want to look at it. Here's that second one, f of 1. Oh, I thought I had that here. Must have deleted it on accident. Let me. Alright, so let's do the next one. F of, gosh dang, f of x, okay. So what is f of x? F of x is 1 over x plus 2. So 1 over x plus 2 is going into f. So now let's write f. F is 1 over x plus 2, and that goes in right there. 1 over x plus 2. And at this point we say, alright, domain, for sure, negative 2 is out already. Again, I'm going to look at it right there. If x is negative 2, not going to work. Now we got to clean this thing up, put it over 1, x plus 2, x plus 2. So this becomes 1 over 1 plus 2x plus 4 over x plus 2 multiplied by the reciprocal, and I got x plus 2 over 5 plus 2x, or 2x plus 5. The denominator cannot be 0, so where's 2x plus 5 equals 0 when x is negative 5 halves. Negative 5 halves also causes a problem for this f of x function. So negative 2 as well as negative 5 halves. Both of those cannot be a part of my domain x such that. Okay? Alright, so what about if you're finding, here it's just showing you, you'll have some of your homework like this, show that f of g of x is equal to g of f of x, which equals x. So you're going to go through that exact same procedure again. You know, you're going to throw g into f. So here's our g, it's going into the f. The f function is 3x minus 4, so that goes in, x plus 4 over 3, and you see you end up with x. And you go the other way around, g of f of x. Now here's your f. Now you're using g, which is 1/3 x plus 4. 1/3, here's your x plus 4, and that f is going in for x right there. Right? Clean that up and you get x, and you show that you have f of g of x equals g of f of x. Alright, how about backwards? So what if you find the functions f of g such that it equals h? So if h of x equals x squared plus 50, in other words, f of g of x is x squared plus 1 to the 50th. You know, what's your g and what would be your f? So what I always like to do is I think about this in terms of who's little and who's big kind of deal. So I make my inside part, if you will, that I'm going to make my g. So my g of x is x squared plus 1. And then I make my f of x, whatever that junk is, that junk becomes my x, so that's my x to the 50th. And that will be one that would work. This is, by the way, not the only one. I'm sure you could probably think of some other ones, but let's go ahead and check it. F of g of x. So we got, let's see, our g here we're claiming to be x squared plus 1, and now we're going to throw it into f, and our f is x to the 50th. X to the 50th. Who goes in? Our g. X squared plus 1. Is that what we started with? You bet it is. So there's an f and a g that works for us. Here's another one. What about if f of g of x is this 1 over x plus 1? Well, what would g be? I'm going to make the inside part, if you will. I'm going to kind of think about that as my parentheses. So I'm going to make that g of x be the x plus 1. So that's like my input, right? So my f of x would have to be 1 over that input, so 1 over the x. And then you can test that as well. F of g of x, our g is supposed to be x plus 1. So x plus 1 goes into f. F is 1 over x. But what goes in? G. X plus 1. That's what we started with. 1 over x plus 1. Then we talked about that. All right. Appreciate you guys listening, taking the notes. We'll see you in class.